The story goes that in 1666, Isaac Newton decided to take a break from his work and go sit outside in the sunshine. He sat underneath an apple tree when suddenly an apple fell from the tree above him. And he then started to wonder why the apple was falling towards the earth. What was causing this to happen? So Isaac Newton deduced that gravity was the force between any two objects that would pull them together. It doesn't matter what their masses are or what their separation is. It doesn't matter if they're the apple falling down to the earth, or they're two incredibly massive galaxies on the other side of the universe pulling towards each other. And he was even able to express this gravitational fundamental force of nature in the form of an equation. And even better, it's a really simple equation. All it depends on is four simple things: a constant, the mass of both of the objects, and their separation between them. Using this equation, you can work out the force between any two objects in the whole universe. So this explains why the apple falls to the earth. Because both the apple and the earth have mass, there's a force between them pulling them together. But just as the apple falls towards the earth, because of the force of the mass from the earth actually also moves towards the apple. It's just that the mass of the earth is so much bigger than the apple that we don't actually physically see or feel the earth moving towards it. But technically, both are actually meeting together in a sort of middle point between the two objects. But gravity doesn't just pull two objects together until they collide. It's also the reason that the Earth, the other planets, comets and asteroids all orbit around the Sun. It's the mass of the Sun that creates a gravitational force that keeps the planets and everything else orbiting around the Sun. It's the gravitational pull from the Sun that keeps the Earth orbiting around it. If the Sun would suddenly disappear, there'd be no more force on the Earth holding it in place, and the Earth would simply just fly away. So the gravitational pull from the Sun is clearly very strong, as it holds all the planets in place orbiting around it. But if it's so strong, why don't we attract it more towards the Sun? Why are we stuck down here on Earth? Why don't we just float off towards the Sun? Well, we have to look back at Newton's equation. And in Newton's equation, you have the mass of the two objects. One is the mass of us, and one is the mass of the Sun or the Earth. We know that the mass of the Sun is much larger than the Earth. So in this case, you think that the force is much greater. But the really detailed thing in the equation you need to look at is the value of r, the separation. Because we're much closer to the Earth, because we're already stood on it, the force by the Earth on us is much stronger, so it keeps us stuck down onto the surface of the Earth instead of floating towards the Sun. However, this means that if you go into outer space, there's a point in between the Sun and the Earth where you feel more gravitational attraction from the Sun than you would the Earth. So at this point, you then start being pulled towards the Sun instead of from the Earth. So we know that gravity works over all distances, whether very small or very large. But we know that as the distance gets larger, the force of gravity becomes much smaller. But this has a very surreal impact. This means that you are attracted to any other object with mass throughout the universe, no matter how far away it is or what its mass is. So this means that you are being attracted to the Sun, which is very large mass, very close to us. But you're also being attracted towards a grain of dust on the other side of the universe. Now the force from this grain of dust is really small and doesn't really have any significant impact on you, not that you could ever notice, whereas the Sun does. But you are still feeling gravitational force from this incredibly small grain of dust on the other side of the universe. But whilst gravity works incredibly well over large distances, over short distances it's actually pretty weak, at least compared to the other fundamental forces, like magnetism. And actually there's a really simple way of showing how weak gravity actually is. Now to demonstrate this, all we need is a magnet, such as this fridge magnet, and something metal like a screw. Now, if we hold the magnet above the surface of the Earth, pointing downwards, the entire magnetic force just comes from this magnet pulling up, whereas the force of gravity comes from the entire mass of the Earth. Now, you think that the mass of the Earth, the gravitational force that it creates, will be much stronger than this tiny magnet. But if we put the magnet and the screw together, you can see that the magnet holds up the screw against the entire mass of the Earth. So this small magnet creates more force than the entire Earth. So gravity is relatively weak compared to some of the other forces in the universe. So gravity is clearly important. It holds the solar system together with all the planets going around the Sun. It holds me and you down onto the surface of the Earth so that we don't float away into space. Understanding gravity is fundamental to science and physics. So I suppose it's pretty good that on that nice warm summer's day, Isaac Newton decided to go outside, have a nice rest underneath an apple tree. Thank you very much for watching. Don't forget to like, subscribe, check out the rest of my videos, and I'll see you guys soon.